The James Webb Space Telescope is all set to probe a star's unexplained dimming and massive black holes that are growing at suspiciously fast rates. It's even tasked to investigate an exoplanet that's mysteriously losing mass. But let's not get ahead of ourselves. Before we explore these thrilling adventures, let's quickly revisit what makes Webb a behemoth in space exploration. The James Webb Space Telescope, or Webb, is a sight to behold. Its size alone sets it apart, being nearly 3 times larger than any space telescope ever launched. But its size is not for show, it serves a crucial purpose. The primary mirror of Webb is a marvel. At 6.5 meters in diameter, about the size of a 2-story building, it's designed for one key task: capturing infrared light. The mirror is divided into 18 individual gold-coated segments optimized for this very purpose. Infrared light is special. Unlike visible light, it can pass through the dust. That's vital for space exploration because much of the universe is hidden behind cosmic dust clouds. With its infrared capabilities, Webb can reveal what's been concealed. From young stars in thick nebulae to galaxies at the edge of the observable universe. But Webb is more than a giant infrared mirror. It hosts 4 advanced scientific instruments, each packed with its own suite of sensors. They are the telescope's eyes and ears, capturing data in unprecedented detail to fuel new discoveries. Let me tell you, Webb has made some jaw-dropping discoveries. The most awe-inspiring? Finding the oldest known galaxy, all the way in the Fornax cluster. This bad boy came to be when the universe was only a toddler, a mere 2% of its current age. Then, turning its powerful gaze a bit closer to home, it's been peeking into the ins and outs of galaxies, star clusters, and those beautiful space clouds we call nebulae, like that stunning group of galaxies, Stephan's Quintet. Using its super advanced tech, Webb has spotted all sorts of new stuff about how stars and galaxies grow and change. Now, onto the mystery of exoplanets. You know, those planets that orbit stars outside of our solar system. One in particular, WASP 96b, caught Webb's attention. What was the big find? Well, it spotted signs of water in its atmosphere. This discovery is a game changer. It gets us one step closer in the grand quest for life outside of our solar system. Closer to home, Webb has been hanging out with our big gassy neighbors, Jupiter and Saturn. Its state-of-the-art camera checked out Jupiter's swirling atmosphere, revealing new layers we haven't seen before. And it didn't stop there. It also snapped some fantastic shots of Saturn's iconic rings, and even managed to get a glimpse of its distant moon. To put it simply, Webb has had one heck of a year. It's a cosmic detective unearthing secrets of the universe, our own galaxy, and our solar system. And you know what? It's just getting started. Strap in, because the universe's mysteries are starting to unfold right before our eyes. After a successful year, Webb is revving up its engines for year 2. And the astronomy community isn't playing around. They've sent in a whopping 1,006 project proposals from 52 countries. A selection panel is going to sift through all of these proposals to find the most promising ones. A nice chunk of Webb's observing time, 16% to be exact, is dedicated to the teams that helped build this incredible machine. This is known as Guaranteed Time Observation, or GTO. One proposal that's got everyone's attention is about our good friend Boyajian star. Now, this star is a bit of a rule breaker, flickering and dimming at random with no rhyme or reason. And let me tell you, it got astronomers scratching their heads. It all comes down to the star's light. See, stars typically have a predictable brightness, but Boyajian's star? Not so much. Now, there are a few theories on what's causing this stellar disco, but the main suspect is a bunch of dust rings around the star. How can dust cause this? Well, when a star's light hits dust, it scatters, leading to a decrease in brightness. But here's the thing. Previous observations of the star in infrared light, the kind we can't see with our own eyes, showed no significant dimming. That's a big clue because infrared light can pass through dust relatively unhindered. The proposal is to use Webb's MIRI to observe this star more closely. MIRI is sensitive to infrared light, perfect for peering through dust. If it spots a glow from dust particles, that'll be the smoking gun we need to confirm these dust rings. We might finally understand why Boyajian's star can't keep its light steady. It's like a cosmic game of Clue, and we're hot on the trail. Next up, we have proposal 3079, fondly known as BEES, Black Hole Extended Emission Search, which is like the detective story of the cosmos. Something's fishy because these black holes grew way too fast if they were just snacking on cosmic dust and gas. So the astronomers came up with two scenarios. One, these black holes are gorging at super fast rates, like cosmic competitive eaters. Or two, there's a phase when they're shrouded in dust and growing quietly without us noticing. The plan? Observe two active quasars where massive black holes live. If their lifetimes turn out to be short, it means they're growing super fast, breaking all the cosmic rules. It's a cosmic mystery, and Webb might just crack the case. Then we have the NEAT program, a fancy acronym for NIRISS, exploration of the atmospheric diversity of transiting exoplanets. It's all about studying the atmospheres of exoplanets far, far away. This project isn't just about celestial sightseeing. There are fundamental scientific questions at stake. The aim is to understand the birth and life of these distant planets. What are their atmospheres composed of? Is there cloud cover? And if yes, what materials constitute these clouds? Is there any peculiar chemistry going on that we can't yet comprehend? The program will use Webb's advanced capabilities to probe these questions. One focus is on understanding the vertical temperature structure of the hottest exoplanets. This data can tell us a lot about a planet's atmospheric dynamics and weather. But there's more. The NEAT program also plans to measure the mean molecular weight of rocky planets in their sample. This information is vital for understanding the composition and structure of these planets, shedding light on their geological and atmospheric evolution. And last, but certainly not least, Proposal 3315. It revolves around the in-depth study of K2-22b. It's an extraordinary Neptune-like gas giant orbiting a red dwarf star about 801 light-years away from Earth. The planet's mass is about 1.4 times that of Jupiter, a hefty weight even by gas giant standards. But what's truly astonishing is the rate at which this planet is losing its mass, around 300 million kilograms per second. As K2-22b orbits its star, it leaves a trail of debris in its wake, causing a peculiar dip in the star's brightness every 9 hours. Scientists believe that by studying this debris, they could potentially determine what the planet's interior is composed of. Webb will play a crucial role in this investigation. Its susceptible instruments will examine the debris in unprecedented detail, helping to reveal its chemical composition. These observations could ultimately shed light on the planet's history, its atmospheric conditions, and even the processes that are causing it to lose mass. K2-22b is like a disintegrating celestial body that's literally coming undone. Studying this fascinating object could provide critical insights into the life cycles of gas giants, and perhaps even the universe itself. Each of these projects is going to be a game changer, offering fresh insights and potentially rewriting what we know about the cosmos. From stars that just can't behave to black holes that have a serious appetite, from peculiar exoplanets to gas giants behaving badly, the James Webb Space Telescope is like our golden ticket to the greatest show in the cosmos. With its second year on the horizon, we're practically giddy with anticipation for the new cosmic secrets it will unveil. Make no mistake, Webb isn't just a telescope. Oh no, it's a time machine and a cosmic sleuth offering us a peek into the mysterious corners of the universe. It stands as a brilliant monument to our insatiable curiosity and the relentless human pursuit of knowledge. But don't forget, the universe isn't done with us yet. Not by a long shot. We've got another thrilling cosmic adventure up our sleeves. Check out our video on James Webb Space Telescope's search for exoplanets to find one most suitable to call our second home. After all, in this never-ending cosmic sandbox, the possibilities are as boundless as the universe itself. Who knows what we're going to stumble upon next?